Hello AP Statistics students. In this video we are going to finally calculate outliers. We've been talking about it for a long time. We've been finding probable outliers, but now we're actually going to mathematically calculate them. We're going to look at 5 number summaries and explore how you make those into box plots. So our objective here, we will determine if a data set has outliers and use 5 number summaries and box plots to compare and describe distributions. So, first one, how many goals does it take to make an outlier? So, here are sorted data on the number of goals scored in 20 games played by the 2016 US women's soccer team, along with a dot plot. So we got the numbers in order. That's always nice. That's a very tedious thing. We've got the dot plot. We want to identify outliers. So to do that, you first have to find the median and break the data in half, and then break the data in half again to find Q1, quartile 1, and Q3, quartile 3. That lets you find the interquartile range, which we have found before, and that is what outliers are based off of, that interquartile range. So hopefully you follow that. The IQR in this case, Q3 minus Q1, is 4.5 minus 1. So our interquartile range is 3.5 goals. All right, so we're going to use that 3.5 now to find the outliers. So the lower outliers, what they did is any number that is less than 1, which is the Q1. So quartile 1 happens to be a 1, so they do 1 minus 1.5 times 3.5, the interquartile range. So what you do is you take the distance of this interquartile range, which is from here all the way to here. You take that distance, and then you go 1.5 times that distance to the left. And that is the cutoff point for outliers. So that's what this math is doing. Here is Q1, it's a 1, minus, this is going to the left, 1.5 times the distance of the IQR. And then that goes way over here at negative 4.25. So way over here, if I went all the way to negative 4.25, that is the cutoff for a lower end outlier. And of course, the data doesn't go that far, so there are no lower end outliers. But if we look at the bigger end, it kind of looks like 9 or 10 might be outliers. So again, what we do is we take this IQR distance and we go 1.5 times above Q3. So a higher outlier is any number that is bigger than Q3, here's Q3, plus, we're going to the right, 1.5 times the IQR, the interquartile range. So we're taking this distance right here, and we're going 1.5 times to the right. Where does that land? Do the math, and they get 9.75, which is right here. So anything above that is an outlier. So the 9 was not an outlier, but the 10 is an outlier. That's how you calculate outliers. So let's write those steps here. So first, you do need to order the data so that you can find Q1 and Q3, which allows you to find the IQR. Once you have the interquartile range, I would probably just find the quantity. Not sure why that's going up and down. Sorry about that. Quantity. Interesting. Quantity. 1.5 times the IQR. Okay. Once you have that value, you subtract from Q1 to find lower value, or lower, let's call it a limit. Add to Q3 to find upper limit. And those will give you the cutoff points for outliers. Now, if you take a look at your alligator signs here, there is no equal to sign. So if you do have the odd occurrence where a data point hits right on that limit, so let's say there was well, that's impossible, but for the sake of learning, let's say there was 9.75 goals scored, that would not be an outlier. Anything that is bigger than, not bigger than or equal. Probably not gonna happen, but there it is. All right, so back to some pictures. 5-number summaries. A 5-number summary is simply a list of the min. I'll go this way. The min, Q1, the median, Q3, and the max. Those 5 numbers are your 5-number summary. Now, what is that good for? Those are the numbers you use to make what's called a box plot. Outliers are also important for box plots. We will put the outliers on there. So here's a worked out example here of what you got to do to make a box plot. So first you take your data, you have to organize it from least to greatest or greatest to least. It has to be in order, because once it's in order, you can find your median, you can find Q1 and Q3. So what's our context here? Some students purchased pumpkins for a carving contest. Woot woot. Before the contest began, they weighed the pumpkins. The weights in pounds are shown here. So they just weighed a bunch of pumpkins. Okay. So we're going to make a box plot for this and then put our outliers on it, I believe. So they started a lot of this calculation for us. The IQR, interquartile range, is 8.7. They just took 12.7 minus 4, gives you 8.7. So our lower outliers, they took Q1, which is 4, minus this distance, 1.5 times IQR, gives you negative 9.05. So definitely no lower outliers, because you can't have a pumpkin that weighs a negative. Time and space do weird things, apparently. Higher outliers, so Q3, which is 12.7, plus that same quantity, 1.5 times the IQR, gives us 25.75. So were there any bigger than that? Looks like we've got 2. From 15, it jumps up to 31 and 33. So we've got those 2 that are indeed outliers. Now that we've got that information, we actually do have the 5-number summary in here. We can now make our box plot. So let's draw that. It starts out with just a nice number line. Then you have to put your scale for your data. Our minimum is 2 and our max is 33, so we're essentially going from 0 all the way up to 35. So 10, 20, 30, and then if I count by 5s in between, that should get me to 35. And 25. There we go. And of course we should label this. This is the weight of the pumpkins. In pounds. All right, labeling it is very important. All right, so now to set this up, we are ready for our box plot. Let's choose a color. Let's go red. So first you put a mark at the minimum. Our minimum is 2. So right about here is where 2 would be. Put a line there. It's called a whisker. And then you put the Q1 at 4, which is there. And then the median, which is 6.6, which is about yonder. And then Q3, which is 12.7. So 10, 11, 12.7, about there. And then you would put the max, which is 33, in a similar fashion, but I'm going to erase that in a bit, so bear with me. And then you would box the middle like this. and draw whiskers out to the ends. Also sometimes known as a box and whisker plot. There we go. Now, we do include outliers, so I'm going to erase this part on the right because I've got some outliers over here. I don't want, hopefully it looks a little weird for this whisker to shoot out way over here. It's only shooting way out of here because of our two outliers. So to give a better idea of what this looks like, what we do is we mark the outliers with X's. So 33 is an outlier, so right here I'm going to put an X for that outlier, and then 31 is about right there. I'm going to put an X for that outlier. Then I'm going to put the edge of my whisker at the next number, which is 15. So here is where my whisker is actually going to go. Now we can see that gap right here in the middle between 15 and 30. Our whisker used to travel that whole distance. That was a little misleading. The only reason it was that far was because the two outliers, so we take them out of the whisker, and then the whisker just goes to the next biggest number. That also happens on the smaller end as well, if there are lower outliers. Now, there's our box plot. What is the power of the box plot? Well, it shows spread really well, okay? Remember our Q1, our median, and our Q3 are what was made up of this box plot. And what that means is 25% of our data is right here. 25% of our data is right here. 25% of our data is right there, and 25, discounting the outliers, of course, 25% of our data is right there. It shows how we are grouped. So here we have a big cluster, all right, where their numbers are all squished together between 4 and 6.6. 25% of our data is between 4 and 6.6. That's a very tight cluster. But then it spreads out a little bit. From 6.6 all the way to 12.7, that's the spread of the next 25% of our data. So it really shows you how spread out the data is. That is the power of the box plot. I believe we had one more question up here. Explain why the median or IQR would be a better choice for summarizing the center and variability of the distribution of pumpkin weights than the mean and standard deviation. Great question. All right, why median and IQR instead of average and standard deviation? Well, the downfall of average and standard deviation, they are not resistant to outliers. Here we have some massive outliers. They're almost double the next biggest data point. So the mean would get pulled by these outliers. The standard deviation would be inflated by these outliers. So they would not be good measures of center or spread because they are not resistant. You might write that down. But the median and the IQR are resistant to those things. All right. When I first learned about box plots, etc., I was told that you are not supposed to infer shape from a box plot, but you kind of can, okay? And I've seen questions on the AP test and in the book that ask you about shape from a box plot, and you kind of have to get creative. So here's a great example of a dot plot, and you can all definitely see that this data is bimodal. This is the duration of Old Faithful in Yellowstone, actually, of how long that geyser blasts off. Kind of cool that that's bimodal, even though it's real data. Bimodal does happen. So now we're going to pretend that we don't know this is bimodal. Let me cross that out. All right, pretend you don't know that, and look at the box plot. How can we infer that this is a bimodal box plot? It's not easy. So again, you have to think about clusters and spread. So remember, there's 25% of the data right here. 25% of the data right here, 25% of the data right here, and 25%, not to be too redundant. Now, if I look at this 25% of the data must be really close together. That is a cluster. All right, the data is close together. There's a lot of it there. Here, the spread is much more in this 25%. So this is much more spread out in this part of the distribution because it's such a big part of my box plot. That 25% of the data is stretched between 2 and 4, whereas this part of the data is only stretched between 1.5 and 2. And then again over here, you see how our box plot is again pushed together. This is another cluster. Okay. So if we have a group of data over here clustered together and a group of data clustered over here together, spread out in the middle between them, that makes you think bimodal. Okay, and so you can sort of do that logic to think about the shape of a distribution even when you don't have a nice picture like a dot plot or a histogram. So let's try to do that here. We're going to compare two distributions using box plots. Okay. All right, so in a recent year, Consumer Reports rated that many tablet computers for performance and quality. Based on several variables, the magazine gave each tablet an overall rating, where high scores indicate better ratings. The overall ratings for the tablets produced by Apple and Samsung are given here, along with parallel box plots and numerical summaries of the data. So here's the hard data here, but they put it into box plots for us. They even gave us some summary statistics here. So here's our 5-number summary: min, Q1, median, Q3, max. They give us the interquartile range already, thank you. They also give you the mean, x bar, and the standard deviation, s of x. Compare the distributions of overall rating for Apple and Samsung. All right, comparing distribution. One thing should jump out to your mind: socks. All right, so first, shape. So we look at these, oh, shape from a box plot, really, again? All right, so I look at these. What do I see? I see that this right here is very spread out, and this right here is a cluster. So this again has just as many numbers as this does over here. This is the top 50%, this is the bottom 50%, but this over here is much more spread out. So I'm thinking this would look something like this. All right, the bottom 50% is very spread out. The top 50 is much closer together. That tells me skewed to the left. Okay. And then I take a look at this one and I see this is highly clustered here and this is pretty close together. These are all really close together. This one is a bit bigger. All right, I'm thinking kind of the same thing actually. This is looking maybe less so, but still somewhat skewed to the left. So both distributions are skewed left. So the distributions of context of tablet ratings for Apple and Samsung are both, why does my computer keep doing that? My goodness. Skewed left. All right, shape. Outliers. Do we have any outliers? Well, this gives us amazing data right here. We have 2 outliers. Apple has 2 outliers. Apple has 2 lower outliers at, can I find them? It doesn't really tell me. One of them would definitely be the min, right? 73. So Apple 73 and is it 76? It looks like 73 at scores of 73 and 76, Samsung had no outliers. All right, we have shapes, outliers, center. Well, now we got to make a decision because we've got two centers. We've got median and we've got the means. Which center should we use? So now we have to think about resistance, okay? Both of these distributions are skewed left, and that skewed left will affect the mean a lot more than the median. And not to mention the outliers here will also pull the mean too much. And so we don't want to use the mean if we have skewed data. So we want to use the median. All right, so that's kind of like an asterisk here. All right, we don't want to use the mean because our distributions are both skewed left. All right, but now the answer here is, again, we're comparing the data here. So I'm going to go to the medians, 84 and 83. So Apple has a higher median score of 84 compared to Samsung's average. Average score of 83. All right, and last but not least, spread. This is not looking very nice, is it? There we go. Let's space this out, make it look a little bit nicer. There we go. Now spread. So what can we say about spread? Well, we got options. We've got the standard deviation. That is a measure of spread. We could talk about that. How many on average or typically how far away is data from the mean? But standard deviation is not a resistant measure. So we don't want to use the standard deviation because our data is skewed left and has outliers. So we have to use the IQR. So what can we say about the spread? Well, the IQR for Apple is 3 and 11 for Samsung. So the distribution of ratings, I guess we could call it, is much more spread out for Samsung let's capitalize that, with an IQR of 11 points compared to Apple with an IQR of only 3 points. All right, so again, you do want to compare them to each other. So my comparison statements, okay, Apple has a higher median. Samsung has a larger spread, okay? Those comparisons are really what to get at, as long, in addition to the actual stats of telling me what the median is and what the IQR is. You do want to actually compare them. All right, so that is how we can use box plots and the 5-number summary and outliers to compare distributions.